we are given n integers and we want to prove that some subset has a sum divisible by n. So in general, like if you take these some numbers and then in reality, this is a very simple idea. It's almost impossible to try to do the opposite because there are n numbers, say n numbers, and then the number of subsets is 2 to the power n, right? Even if you do like 10 numbers, then the number of subsets you get like 10,000, 1024. So the number of subsets compared to n is very huge, and trying to build a build a set of numbers where every subset has a sum which is not divisible by n. So if you try to do the opposite, it's a very complex problem. But uh, like immediately you can see that there will be a subset that has a sum divisible by n. But the idea is to prove it, and then this problem is just to demonstrate one general idea. So this idea is very common, very common in coding problems in algorithms. So something like prefix sum or postfix sums, sum of sum of uh, certain amount of terms of a set. So that makes a subset, right? So the idea how we prove this problem is very important rather than the problem itself or what we are proving in the problem. So there are n integers, and then at least one of them is divisible by n. So just imagine the following subsets, and then the following subsets and their sums. So like first number, first and second number. So like these are the prefix sums. So imagine these prefix sums. So the first one is basically the first set, A1, A1 and A2, A1 and A3, A2, A3, A1 to AN, all the numbers. So we have here n subsets. So imagine that if we have at least one of them divisible by n, it means that already proves the statement of the problem, right? We have subset that's divisible by n. So what we are going to do, like we will assume that Si, all these S sums, they are not divisible by n, any of them. So if it means it will have some remainder. So the remainder set of when divided by n is, so it will have remainder of 1, 2, 3, up to n minus 1, right? One of these numbers. So we don't include 0 because it's not divisible by n. If it's divisible, then already proves the statement. So this set has n minus 1 terms, n minus 1 elements. But we have n subsets. So by Dirichlet principle, what does it mean? It means there will be a subset. There will be two subsets which have same remainder when divided by n, because n minus 1 is not enough to make all distinct n subsets. So which means there will be some kind of Si and Sj which have the same remainder x when divided by n. So what happens if I do, so let's say I is less than j, right? What happens if I do the subtraction Sj minus Si? So Si is basically A1 plus up to Aj, right? and then you are subtracting a1 plus up to ai. So first I terms will get cancelled out. The result is going to be ai plus 1 up to aj. Since sj and si, they have both of them have same remainder when divided by n, this sum from ai plus 1 to aj, it will be divisible by n, because this one has the remainder x and then this one has the remainder x. When you do the subtraction, the remainder gets cancelled, that becomes 0. Now this subset has a sum which is divisible by n. So looking at these prefix sums and prefix sums, you have two options. First, either one of these n numbers is divisible by n, then it proves the statement. If none of these are divisible by n, then you can find two whose difference is divisible by n. That also works for our statement of the problem. There will be a subset of a's that's divisible by n. So this idea, the idea of prefix sums, is very common and very useful strategy to prove a lot of problems or do some kind of algorithms.